Hello students, welcome you all to the CBSE Chemistry lecture series. In the previous video, we explained all the colligative properties and abnormal molecular masses in solution chapter of standard 12. Now in this lecture, we are going to discuss about ideal and non-ideal solutions. Ideal and non-ideal solutions. So on the basis of Raoult's law, the liquid-liquid solutions can be classified as ideal and non-ideal solutions. Ideal and non-ideal solutions. So this is actually based on the Raoult's law. Yes, what is an ideal solution? A solution which obeys the Raoult's law. See the spelling Raoults. That is called an ideal solution. Whereas the non-ideal solution is a solution which does not obey the Raoult's law. Here you have to say does not obey. Okay, that is the main difference between these two things. Now we will discuss ideal solutions. In which cases the solutions can be an ideal. When we have two components, or you can say solute and solvent, say for example A and B, while mixing the two components, the delta V, the delta mixing of V is equal to 0. That means while mixing the two components, there will not be any change in the volume. That is a ideal solutions conditions. Suppose if it is during the mixing, there is no heat evolved or heat absorbed, that is called no enthalpy change, that is also 0. So while mixing the two components, if volume is 0 and delta H is also 0, and one more aspects, the interactions between the component A and B is equal to the pure component of AA and BB. These interactions will be similar in the case of ideal behaviors. And then one more difference, do not form azeotrope mixtures, do not form azeotropes. Whereas in the case of non-ideal solutions, delta V is not equal to 0, delta H is also not equal to 0, and the interactions of the components AB is not equal to AA and BB, and it forms azeotrope mixtures, That's some of the differences between ideal and non-ideal solutions. We will discuss detailedly with the examples. Yes, this case ideal, generally an ideal solution will satisfy the following conditions as what? Delta V equal to 0, delta H is equal to 0, and practically no solution is ideal. Practically no solution is ideal, but at very low concentration, but the solute concentration is very low, or you can say dilute solutions. The solutions behave ideally. The solution mixtures behave ideally. So for examples, few examples are: number 1, benzene, toluene. So in these two structures, a slight structural modification is a benzene structure. Apart from the benzene, one more CH3 group is there, then it is called toluene. These mixtures will behave ideal. The another one example is what? N-hexane and N-heptane. Okay? Yes. Suppose in this ideal, suppose if it is a graphical representation, This side we are having the vapor pressure and this side we are having a mole fraction. If chi A is equal to 1 here and chi B is 0 this end, and here it is chi A equal to 0 and chi B equal to 1. Suppose if it is a so this is partial pressure of A, this is partial pressure of B, and the P total is equal to PA plus PB. This is a graphical representation of a ideal solutions. Already we have given some examples like benzene and toluene, or these two are ideally behave, or you can say examples for ideal. Whereas in the case of non-ideal we are having two things. One positive deviation, another one is a negative deviation. Positive deviation, another one is a negative deviation. What is my positive deviation? What is my negative deviation? Yes, in that case positive deviation is nothing but if delta V mixing is equal to positive values and the delta H is also positive and the P total is greater than chi A into partial pressure of A plus chi B into partial pressure of B. These are the cases for positive deviations, and we can give some examples. What are those examples? Acetone plus ethanol will show a positive deviation, and CCl4 plus benzene, and these are all forming a minimum boiling azeotropes. Minimum boiling azeotrope. Whereas in the case of negative deviation is, you have to think about, if negative deviation is delta V is negative and delta H is also negative and the P total is less than chi A PA plus chi B PB. We can also give some examples for negative deviations. In this case, chloroform plus benzene. The another one example is what? HCl plus water, and this will forming a maximum boiling azeotrope. So we can also express this positive and negative deviations in the graphical representations. Let us explain graphical representation. So first one will take a positive deviation. This y-axis is a vapor pressure increases in this manner. Here it's a mole fraction. This end chi A is equal to 1, chi B equal to 0, whereas in the case of what? This end chi A is equal to 0 and chi B equal to 1. The first one is a ideal behavior. If it is a positive deviation, it will be higher than that one. You have to draw like this. And for this case, you have to draw like this. Slightly higher than the ideal behavior, and this one is slightly higher than the ideal behavior. Whereas in the case of negative deviation, it should be like this. Yes, you have to mention all these things. This is what P total is equal to PA plus PB, partial pressure of A component, B component. Here it is, this one is a PA, this one is a PB. Yes, these are the graphical representation of a positive deviation as well as negative deviations. The another one is a azeotrope mixture. We will discuss azeotrope mixture. Yes, we will discuss azeotropic or constant boiling mixtures. Constant boiling mixtures. So what is meant by azeotrope? In the case of solutions showing a positive deviation from Raoult's law, and at one of the intermediate composition, the total vapor pressure is the highest. That if it is a positive deviation, Another one is a negative deviation. So in this case, and at one of the intermediate composition, the total vapor pressure is the highest and the boiling point is the lowest, and vice versa for negative deviations. Vapor pressure is what? Lowest, and the boiling point is highest. So here azeotrope mixture, azeotrope is a type of a liquid mixtures, is a type of liquid mixtures having a definite composition, and boiling like a pure liquid is called a constant boiling mixture. Constant boiling mixture or azeotrope mixture, azeotropic mixtures, or simply you can say azeotrope. That's all. And one more example for this case, a minimum boiling azeotrope. Minimum boiling azeotrope is ethanol water mixture. And maximum boiling mixture azeotrope is water HNO3 mixture. Thank you, students. If you have any doubts, please mention in the comment box. Thank you, students.